Good everyone, my name is Graphics. If you look at your screen, you see a question there, and the question says, the efficiency of a heat engine is 36%, which is the working principle in a Carnot cycle. The heat engine received 600 kJ of heat energy at 730 degrees Celsius. Roman figure 1 determine the net work done. Roman figure 2 the heat rejected. Roman figure 3 temperature at which the heat is rejected. Now this is Kelvin Planck statement. When you talk about heat engine, we're talking about Kelvin Planck statement. And you should know one thing for sure, that every heat engine, a good heat engine, has two reservoirs. The reservoir with high temperature, which is called the source, and the reservoir at low temperature, which is called the sink, right? So let me use this to represent my reservoir at high temperature. I will call it TH, T sub H, right? And let me use this to be the heat engine. Are we good? I'll use E here to represent my heat engine. Then let me use this to be my reservoir at low temperature, right? TL. Now we know the high temperature heat, the high temperature reservoir is meant to transfer heat, right, to the engine. Is that taken? So we'll call the heat is transferring to be what? QH. Now the engine is meant to convert the heat that is absorbed by it into a work. There will be work done by the engine on the surrounding. We'll call it the work out. I will good, so I'll call it summation of what? Of W if I want to. Now, not all the heat that is absorbed by the engine that will be converted to work. Some of the heat will be what? Rejected. So we use QL as the heat ejected. So the heat ejected from the engine will be at low temperature, that we'll call it QL, into the reservoir at low temperature, which is what? The sink. All together now. Now this is what we have here. So let's now interpret our question. So when you are given a question like this, you draw this. When it's an heat engine, this is what you draw. So let's see how we can write our parameter and fill in this diagram we have here. Now it says the efficiency of the heat engine is 36%. So we use this to signify our efficiency. We call it the thermal efficiency. And that's given as what? 36%, which is essentially saying 36 over what? Over 100. Right, which is given as 0.36. Now we have the temperature. It says the efficiency of a heat engine is 36%, which is the working principle in a Carnot cycle. The heat engine receives 600 kJ of heat. Are you with me now? So that is QH. So since this is the heat received by the heat engine, we call it what? The QH, since it's coming from the source, the reservoir of high temperature. So we'll call it QH and given as what? 600 kilojoule. Now continue. Then of heat energy at 730 degrees Celsius. So that means the reservoir that is rejecting the heat, that is distributing the heat, has its own temperature of what? 630 degrees Celsius. So my TH is 730 degrees Celsius altogether now. So the same thing is, we're not told to calculate the net work done, that is summation of what? W, right? Or we're looking for, since it is going out, it will be negative of what? W, summation of W, that is the net work done. And the next thing is we should calculate for the heat rejected. So heat rejected is always by the heat engine, and that is what? Giving us QL. QL is the heat rejected. Are we good? And the next one is the temperature at which the body is rejected, at which the heat is rejected, and that is the temperature of the reservoir of low temperature, right? We want to know the temperature of the what? Of the sink. All together now. So we'll call it TL. And we know the temperature of the sink is lower. than that of the source. Are we good now? So we're looking for TL. So these are the data given. We know what QH is already. This is what we have here. So let's move forward. So one thing you need to know before we proceed, we need to understand what a reservoir is. Are we good? A reservoir is a large body through which energy, heat can be added or removed from. Any large body that heat can be added or removed from. Are we together now? That is what we call a reservoir. So the heat engine is what converts this heat to work. Are we together? So move forward. So from the question now, we're told we should do what? Calculate the net work done, right? That is the summation of what? The W. So from the formula that says that the efficiency is equal to the work output, right? All over what? The heat absorbed by the engine, right? That is the formula here. So since the work output we're using negative summation of TW all over what? QH. Are we good? Now the efficiency here given from our parameter is given to be 36 over 100 equals to summation of minus summation of the W, that is the network output, because it's network output we're having negative there, all over the QH here, that is the heat that is absorbed by the engine is the QH. Look at it, it's going into the engine altogether, and that is 600. So what we'll do here is cross multiply. So we're having negative, that is the network done here, will now give us 36 multiplied by 600 all over 100. And my network done negative, the W will now give me 216 kilowatts. So the negative there is telling me that what it is work output. Work output is always negative. Altogether now is negative here. For a good engine, the work output should be, for heat engine should be what? Negative. Altogether now. So we have this. Now the next thing here we're told to do is to look for the heat rejected. So from the formula, from the first law of thermodynamics, that says that summation of the total heat input, of total heat in the system, plus summation of the total work done is equals to 0, right? So if I take this summation of the W to the other side, it will give me negative. So I'll be having summation of the Q is equals to negative summation of the W. Now when you see summation of the Q means the total heat in the system. So it will be QH minus QL. Why? Because of the QL is leaving the system, right? So it will be negative. The QH is entering the system, so it is positive. So we're having QH minus what? Minus QL equals to minus negative summation of the W. Are we good? Now from what we have here, if I put my parameters here, my QH is giving us 600 minus my QL is giving us is unknown equals to my work output is giving us 216. So now if I do the needful here, right, I will now take the QL will now give me 600, which is the summation of the W minus 216. Are we good? You get logic now? So my QL now will now give me 384 kilojoule. So that is the heat rejected by the engine, right? As you can see. So the next thing here that we're told to do is to look for the temperature at which the heat is ejected. That is the temperature of the sink. So with the relationship between heat and temperature here, we said QH, ratio of the heat input and the heat output is equals to the ratio of the temperature of the sink of the reservoir to that of what? The sink. So QH over QL is equals to TH over TL. So what is the QH? QH is given as 600 all over, what is the QL? The QL given as 384, right? Equals to, now the TH is given as 600. We're going to convert it to Kelvin, so it will be TH will be 730 plus 273, and that will give us 1003 all over what? TL. So if I cross multiply, my TL will give me 1003 multiplied by 384 all over 600. So my TL will now give me 641.92 Kelvin. So if you convert to degrees Celsius, you subtract it from 273, and you'll be having TL equals to 368.92 degrees Celsius. So that is what we have. I will go down. So if you have found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.